An excellent overview of the ArcGIS platform, which is also a good segue into our first guests. They come to us from the City of Raleigh, and they're really using ArcGIS in many innovative ways. And so to talk to us about how they're using ArcGIS, I'd like to hand it over to them. If you could join me in welcoming from the City of Raleigh, Jim Alberque, Julie Kottamala, and Justin Greco.
Thanks, David. So we'd like for you to imagine a city in a surrounding area where 67 new people move in every day. That's roughly the equivalent of a full Greyhound bus pulling into that city, everybody getting off, and everybody deciding to live there. Imagine that happening every day. That's Raleigh. So for those of you who don't know, Raleigh is a city in the southeastern part of the United States. It is the capital of North Carolina and part of the Research Triangle, which is a region known for innovation, research, and that growth. But as you can imagine, that growth puts a lot of pressure on city systems, like our transportation network and utilities and infrastructure. These are the services our citizens rely on every day. But this is where we think that GIS and our GIS team can really make a difference. I'm lucky enough to work with a small but talented team of GIS developers, analysts, and engineers who are passionate about local government and public service, and they build solutions for internal staff and the public to make better decisions, do better storytelling, and do analytics. I'm going to turn it over to Julie and Justin, who are going to walk through some examples of how we're using some of our existing technologies in new ways, as well as implementing emerging technologies to face some of these challenges and allow Raleigh to continue to be a great city.
Thank you, Jim. At Raleigh, we've adopted a configure-first approach to building applications. Tools like Experience Builder and Instant Apps have allowed us to put the app creation in the hands of non-developers. Today, 96 users have configured more than 2,800 apps. And the demand for web apps has never been greater. 370 were created last year alone. This has taken pressure off our development team, who no longer have to maintain every single application. And it allows us to focus on larger projects that may require flexibility beyond what configurable apps can provide. Custom development, however, comes with its own challenges, like keeping applications current with evolving technology. A great example of this is our property research application, iMaps, which is by far our most widely used application. iMaps was first created in the early 2000s as an ArcIMS-based app. Since then, it has been redeveloped multiple times, first with the ArcGIS Flex API, and then with the JavaScript SDK. And last year, we also migrated it to components. And we even have an iOS app built with the ArcGIS Swift SDK. Let me show you how iMaps works. The interface is built with the Calcite design system, which we use across all our applications. Finding property information is very simple. Let me enter an address. And I'm presented with a feature component with lots of valuable property information. We have also integrated with the county's Register of Deeds. I can quickly pull up deeds and plats for the selected property. Residents can also find valuable service information, such as who their elected official is, and when their trash is collected. And for users who want to explore further, we have made over 100 property-related layers available. With ArcGIS and integrations into other systems, anyone in Raleigh is empowered to get the answers they need. Developing with the JavaScript SDK and Calcite allows us to deliver amazing apps faster than ever.
So Justin makes this stuff look easy, but there's a lot of complex engineering behind the scenes, including a lot of integrations with third-party systems. And when that's not possible, we write Python ETLs and host them on ArcGIS notebooks. Next, we're going to talk about geoprocessing and analysis with Julie.
Thank you, Jim. Another challenge Raleigh is facing as we are growing is increasing demand for solid waste and recycling services. The map here shows waste collection routes across all 8 regions of the city. Let's take a closer look at one of the regions at the street level. The green dots on the map represent individual addresses requiring waste collection services. Serving the entire city requires us to continually adjust and optimize collection routes, and here's how we do it. With addresses dataset, street network dataset, a network analyst extension, we have access to network analysis waste collection tool. To configure the waste collection analysis layer, we import addresses as stops, depot location. We specify the number of routes that needs to be created, set the start time and how long the route should take to drive. Finally, set the collection mode to one site at a time to run. The output has created routes for us. It has sequenced the street segments for the driver for collection. Instead of routing to individual addresses, it solves for efficient street coverage, minimizing overlap, while coordinating multiple trucks. With this tool in our hands, we can create optimized collection routes daily, deliver the routes into the hands of our drivers, keeping our residents happy.
With our city's continued growth and development, we create a digital twin to help better understand our city today and how it will change in the future. The buildings in our downtown area were generated with LiDAR data and textured with oblique imagery. We use this digital twin to visualize future developments across the city. One challenge is building developers are not required to submit BIM or CAD models, so we often work with them directly. For example, we received this BIM model of our new city hall, which we can add to the scene. To keep the digital twin up to date, Julie's team regularly collects drone imagery of the construction site. Here is one phase of the construction. And here is the most recent capture. Using the same drone imagery, we have created a Gaussian splat with ArcGIS Reality. When I zoom into the building, you can see incredible detail. Check out the rungs on the crane's ladder. Now look at the lift and the pulley, and even the knots and the grain of the wood beams. All this data elevates our 3D digital twin to help make critical decisions for the future of Raleigh.
Our city is growing, and our traffic intersections are feeling the pressure. The map here shows locations of cameras installed at traffic intersections across the city. Video streams from these cameras are processed using computer vision with AI deep stream model to capture vehicle turn movement and pedestrian behavior data. We've built this ArcGIS dashboard for our transportation staff to visualize peak traffic hours, vehicle turn movements showing number of vehicles moving from one direction to the other, and pedestrian data related to crosswalk usage and pedestrian violations. This dashboard gives a good understanding of traffic data. But for a deeper insights into traffic trends and patterns, we have built an MCP server and integrated it with Microsoft Copilot. Let's ask our agent to give us a breakdown on pedestrian activity at the intersection 3168. Compare the activity for the week of January 12th to the week of March 4th, and see if there is any key patterns or trends that's worth noticing. I'm going to quickly refresh it and try it again. On the left panel, you will see the tools that are available for the agent in the MCP server. Behind the scenes, the agent is calling tools on the MCP server, which connects to our traffic data and ArcGIS and runs the analysis. So these are the tools it's able to access, and it's back with some details. Nice. It has given a breakdown of crosswalk usage for both the weeks. But what I really like here is the trends and observations it has given. There's an overall volume increase by 48%. It's also giving some information on where crosswalk usage dropped by 25%. This is so insightful. We can publish this agent for our transportation staff for better insights into traffic signal timing and traffic flow. With artificial intelligence and ArcGIS, we can turn raw traffic data into meaningful insights for the city of Raleigh.
So there's one more application that we wanted to show you. It's called Raleigh in Motion. It's a 3D application that gives our internal staff a real-time understanding on congestion levels in our city. So like many other cities, we have cameras at all of our major intersections. Those traffic cameras, using NVIDIA technology, we take that video and turn it into data. And then we take that data and we push it into GIS via ArcGIS Velocity. We collect data at these intersections, like turning movement counts, pedestrian behavior, bicycle counts. Additionally, we tie into other real-time data sources, like these micromobility scooters. This gives us a much better and more comprehensive view of how people are moving around our city. Lastly, we can leverage the same underlying technology to detect dangerous situations. So in this video, you'll see a vehicle approach an intersection, slow down, and actually stop in the intersection. The computer vision model is monitoring the situation and labels it as a stalled vehicle. An alert is then generated and reported automatically. With GIS married with other emerging technologies, we get better insights and help to keep Raleigh in motion. We're really grateful for the opportunity to share some of these solutions with you today. And we're excited about the opportunity to continue to push on this and see what's next for cities like ours. Thank you.